Expanding quadratics involves multiplying two numbers, but both of those numbers could be made up of more than one part. Here we've got a number made of two parts multiplied by another number that's made of two parts. Now let's go back to something that we actually know really well. Back in primary school, when we learned how to do these algorithms to multiply two-digit numbers, to do something like this, what we're really doing is two twos, 10 twos, 10 more twos, and 10 tens to make that 100. Then we add all of the bits together and we have our answer. Now to look at this another way, if we had a paddock, or a classroom say, that was 12 metres by 12 metres, if we wanted to break that up with a fence, so that we had a section that was 10 metres and another section that was 2, and another 10 and another 2, you can see our four parts really clearly there. 10 tens, the area of this would be 100, 10 twos, 2 more tens, and 2 twos. So those are our four parts, and we can break them up in any way. Now, to translate that into something that's a little bit harder because it's got pronumerals in it, we can use the same philosophy of saying this number x plus 3 is just a number that has an x part, we're not sure how big that is, and a 3 part, and we're multiplying that by x plus 2. So if we were finding the area of this, we'd have x times x, we'd have 3 lots of x, we'd have 2 lots of x, and we'd have 2 lots of 3. And this explains why, in a way, we've got quadratics here. There are 4 parts to our answer. Now, how do we do this so that we don't need to draw it up either like this, and we don't need to think of it as area? Well, what we need to do basically is multiply each thing by each other thing. And an easy method to do this is to think of the word FOIL. This stands for firsts, outsides, insides, and lasts. So the firsts is the first one of each set of brackets. And if you put one of these lines over, it reminds you what you've already done and what's still to do. So we have x times x, which is x squared. The outsides is the x and the 2. Now don't forget this is not just 2, it's got a plus in front of it, and that sign there belongs with the 2. So x times positive 2 is 2x. Now I is for insides, that's the positive 3 times x, which gives us 3x. And the L is the lasts, 3 times 2, which is 6. Now what you'll find is that the outsides and the insides, if you have the same pronumeral here and here, they'll often actually link up and make like terms. 2x plus 3x is 5x. So on the next line, I can tidy up like that. And I end up with only 3 terms. Now to do one that's a little bit harder, let's include some negatives this time. Let's have x plus 5. All right, let's practice. First we need to do the firsts. That's 2x times x, which is 2x squared. Now the outsides is 2x times 5, which is 10x. And then the insides, don't be fooled here into thinking this is a 3, it's actually minus 3. So we have minus 3 times x, which is minus 3x. And minus 3 times 5, which is minus 15. Now you look for your like terms, plus 10x minus 3x is 7x. So we can tidy up those middle terms to make 7x minus 15.